Well, on julialang Twitter, there was a very interesting question. Hey julialang, is it possible to subset a data frame using a logical boolean matrix like you can in rstats? Anything close would be helpful. So, and the original poster, Mr. Brendan Greenwell, clarified that he's looking for something like DF1b equals to DF2b, where DF1 and DF2 are compatible data frames, and b is a boolean matrix of the same dimension. Works fine with arrays, and just hoping there was a trick to do something similar with data frames. Okay, well, let's investigate what's happening. Well, in R, for example, you can look at create a data frame with 100 rows. I'm going to do this, and 100 rows. So I have DF1 and DF2. They look like this. So just 100 rows of 2 columns for DF1, and the same thing for DF2. 100 rows, 2 columns. And now I'm going to create a matrix with 2 columns and 100 rows each. So that's my B. So as you can see, dim of B, and you can look at the structure of B. Yep, it's Boolean. So what you can do is then assign the positions indicated by where B is true in data frame 2 to where they are in DF1. So let's see what happens. Actually, let's just see what happens if I just run that alone. And you can see it actually takes values from column 1 and column 2, but they all get converted into a string. And we will take this string and then assign it into the appropriate positions in DF1. So let's just run that. And now if you look at what's happening in DF1, B, they are 2 and B. And let's look at the DF1 again. So, well, okay, you can see that now some of the ones have changed to 2. And if you look at the structure of DF1, you see that the whole vector, the whole column A has been changed to string as well. But this is actually working, but it's not perfect because you know, it's messed with the column types. Maybe it shouldn't have. Let's see what can be done in Julia. So this is my Julia. I'm going to do the same thing. I'm going to use data frames. I'm going to create 2 data frames with exactly the same data. So in DF1 I have 1 and A's. In DF2 I have 2 and B's. And again, we're going to do the same thing. We'll just create a random matrix. It contains true and false at random positions. And you see that if I do this index, it doesn't work like in R. It's giving a method error. But Julia is very flexible. This is very easy to fix. So the way to make this work is to recognize that brackets like this is as kind of like a magic method. What's backing it is this function called getIndex, and I can write my own getIndex function because of the multiple dispatch support in Julia. So this is what I'm going to do. I'm going to define a function, and I need to put base.getIndex. If I didn't do that, if I just have that, then I'm basically creating a new function called getIndex that isn't the same as what's in base. So now I have 2 versions of getIndex, and it's not allowed. So let's put it back. And this function is very simple. I will take a data frame, which is an abstract data frame. So I don't basically, you know, you can have many different types of data frames, but I'm saying this function will work for any data frame. It's a subtype of the abstract data frames. And do the same thing. If you pass me a B, if this B is an abstract array of Boolean type of dimension 2, then you know I'll accept it. So any abstract array will work. So the underlying implementation of the array doesn't matter as long as it implements the methods that I need. Okay, so inside this function, the first thing I do is check that the size of A and B are the same. So the size function here is the same as dim in R. I'm going to keep start a results vector that contains nothing at the beginning. I'll just enter an empty vector. So this is what I'm going to do. I think this program can be done in a variety of ways, including using, for example, map reduce or map fold out. But I think the for loop version is the easiest to read. So this is what happens. I take my B, which is the Boolean matrix, And for each row of B, I am going to iterate over it using the enumerate. So enumerate will return the columns of B, and also a number to keep track of which column I'm reading. So this code number will increment starting from 1, 2, 3, 4, etc. But of course B only has 2 columns in this case, so yeah, column number will go 1 and 2, and this B code will be each column of B successively. Okay, so very simple code. I take my empty results, I'm going to concatenate it with the data frame at these rows and this column. And in the DataFrames implementation in Julia, if you pass in a vector boolean, the row filtering already works. This is extracting the values exactly as in R by passing in a boolean column to indicate the rows where you want to extract the values, and by providing a column number. That will return a vector, and I'm concatenating this vector with the results vector. So I ended up with concatenation of the 2 column vectors, and you see the results of this. So I define this function. Oh, gives me a tick, no syntax error. I'm gonna run this. As you can see, it returned 1 on 1 and AAA. And one important thing to notice is that the array was returned with type any. So none of these ones got converted. It gets stored as 1, which is integer, and then these are kept as strings. This is actually quite important because in R, you have to force everything to be of the same type in a vector. But in Julia, that's not a requirement. Although for performance reasons, you probably want to, but in this case, it actually works out better that we don't. Okay, so we've done that. Clearly, this is working, but how do I make assignment work? To make assignment work, I need to extract the correct values and also assign it to the right place. So this is the syntax I'm going to go for. To make assignment work, I have to overload the setIndex method with my types. So the setIndex method is basically a magic method that basically is the left-hand side of this. So again, very simple stuff. I'm going to do an abstract data frame. These are the values I'm going to assign. So we'll take values from here, and this is the location where I want to assign the new values. So inside this function, very simple. Again, I assert that they're the same size. And I am going to get all the index to assign. So I'm going to use this function called findAll. FindAll will just return all the places where B is true in terms of an index, Cartesian index. I'll show you what it looks like. So do this, it will say that the position 3,1 is true, 19,1 is true, 42,1 is true, etc, etc, etc. So these are the places where B is true. And I can use this directly to index into my data frames. Okay, so that's what this is. And then the next thing I check is the length of this, where the B is true, is exactly the same as the length of the values to assign. Because if they are different, then I want to throw an error. I don't want to assign this to this. Next thing, again, very simple. I was going to loop through all the indexes and all the values. I'm literally going to take the index into that data frame at the right place and assign it to that value. And just return the values to assign. That seems to be the thing to do. Let's go through if this thing has worked. Let's assign it. Gives me a tick. No syntax error. So I'm going to look at it. So if I look at the DF1 at the positions of B, it gives me this. You can see that they are 111 AA, and I'm going to assign values in DF2 into DFA. And if you recall, DF2 contains only the values 2 and B. I'm going to do that. It seems to have worked. And now if I look at the DF1B, you see that their value is no longer 1 and A, but now 2 and B. And I can look at DF1, and you can see that it's successfully assigned values. Columns are now 2 and B. So there you go. This is how you can define a method to do assignments by Boolean matrices in Julia. Thank you.